Hey everyone, welcome to another tutorial by Simplilearn. In this tutorial, we will learn about TypeScript. TypeScript has grown in popularity in growing years. Microsoft created and maintains the TypeScript programming language. It is a rigorous syntactical superset of JavaScript with the addition of optical static typing. TypeScript is a large-scale application development language that compiles JavaScript. Existing JavaScript programs are also valid TypeScript programs because TypeScript is superset of JavaScript. Let's see what's in it for you in this session. We'll first start with understanding what is TypeScript. Then we will see why do we need TypeScript, what led to the development of TypeScript. Next we will see some of the important and key features of TypeScript, followed by which we will look at the advantages of TypeScript and applications of TypeScript. Then proceeding further, we will see how to set up the development environment. What are the necessary tools required for the development of TypeScript? Then we will see how variables, data types, functions, and loops are used in TypeScript. But before we begin, if you love watching tech videos, then subscribe to our YouTube channel and make sure you have pressed the bell icon so you never miss an update from Simplilearn. So without wasting any further time, let's get started. What is TypeScript? TypeScript is object-oriented and strongly typed programming language, which is a superset of JavaScript. TypeScript was designed by Anders Hijelsberg at Microsoft. The limitations of JavaScript for developing large-scale applications at Microsoft and among its external customers led to the creation of TypeScript. Because of the difficulty of working with complicated JavaScript code, there was demand for custom tooling to make developing JavaScript components easier. TypeScript code is converted to JavaScript, which can be executed anywhere JavaScript is supported, in the browser, on Node.js, and in your application. TypeScript is JavaScript with some additional features. To support more robust interaction with your editor, TypeScript adds additional syntax to JavaScript. TypeScript is a scripting language that understands JavaScript and uses type inference to provide powerful capabilities without additional code. Why need TypeScript? Now we'll see some of the reasons why we need TypeScript. Firstly, we have compilation. JavaScript is an interpreted language. Thus, there is no need to compile it. As a result, it must be run to ensure authenticity. If there is an error, we need to write the code only to find the output. As a result, we will have to spend hours looking for faults in the code. Error checking is provided via the TypeScript transpiler. If the TypeScript detects any syntax mistakes, it will compile the code and generate the compilation error. This aids in detecting errors before the execution of the TypeScript. TypeScript provides an optional type system for JavaScript code. When a client doesn't have a value for a parameter, he can pass null. Optional arguments are a feature of TypeScript. You can declare some optional arguments in the function by utilizing optional parameter features so that the client does not need to supply a value to optional parameters. Strong static typing. JavaScript does not have a powerful static typing system. Through the TLS, TypeScript comes with an optional static typing and type inference system. The TLS, that is the TypeScript language service, can deduce the type of variable defined with no type based on its value. TypeScript supports object-oriented programming. TypeScript supports classes, interfaces, inheritance, and other object-oriented programming principles. TypeScript supports type definition. Existing JavaScript libraries can use TypeScript type definitions. External TypeScript libraries are defined in TypeScript definition files. As a result, it can include these libraries in TypeScript code. Features of TypeScript. TypeScript supports other JavaScript libraries. TypeScript is a new Microsoft language that is a highly typed superset of JavaScript with the support for object-oriented programming and other current features like decorators. Because browsers and nodes comprehend JavaScript, TypeScript compiles JavaScript. TypeScript is portable. TypeScript is cross-browser, cross-device, and cross-platform. It can run in any environment that supports JavaScript. TypeScript, unlike its competitors, does not require a dedicated virtual machine or a specific runtime environment to run. TypeScript is superset of JavaScript. It's a strong syntactical superset of JavaScript with the addition of optional static typing. TypeScript is a large-scale application development language that transcompiles to JavaScript. Existing JavaScript programs are also valid TypeScript programs because TypeScript is superset of JavaScript. TypeScript is static. When a client doesn't have a value for a parameter, he can pass null. Optional arguments are a feature of TypeScript. You can declare some arguments in the function optional by utilizing optional parameter features so that the client is not necessary to supply a value to optional parameters. Object-oriented programming. When it comes to object-oriented programming with JavaScript, TypeScript shines. Because of the class keyword, it makes object-oriented programming look quite similar to programming in other object-oriented languages like C# or Java. Applications of TypeScript. TypeScript can be used to create both client-side and server-side JavaScript applications. TypeScript can be deployed instead of JavaScript language since it adds more features and gives errors directly with the code. TypeScript is used for building large-scale applications for enterprises. Now let us look at the advantages of TypeScript. During development, problems are highlighted at compilation time. Any browser or JavaScript engine can run on TypeScript. By defining a module, it has a namespace concept. TypeScript supports strongly typed or strongly typing. TypeScript has the advantages of being tightly typed or allowing static typing. It may confirm type correctness at compile time because of static typing. IntelliSense is the feature of TypeScript that develops active tips as you type. Setting up development environment. Firstly, we need to go to Node.js official website and install Node.js. After installing, go to command prompt and type the function node space -v to check if the node is installed properly. To install TypeScript, run the command npm node package manager install globally TypeScript in the command prompt, and this will install TypeScript. So let's jump to the browser and see the installation of Node.js and TypeScript. Then we will go to Visual Studio and see the different components like loops, variables, data types with examples.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit SkillUp by Simplilearn. Click on the link in the description to know more.
So to install Node.js, come to the website nodejs.org. Here come to the downloads, and from here you can install Node.js. Node is an open source server-side execution platform for JavaScript code. Node is commonly used for real-time applications like chat, news feeds, and web push notifications because it allows for a persistent connection from browser to the server. Node.js is a JavaScript runtime based on V8 JavaScript engine from Chrome. Node.js is an asynchronous event-driven JavaScript runtime for building scalable network applications. To install for Windows, click on Windows. If you have Mac OS, click on Mac OS to install. So I'll click on Windows. Here we go. Node.js is getting installed. Since I have already installed in my device, I'll cancel it. So once the installation is complete and you have installed the Node.js, next go to command prompt. In the command prompt, run the command node-v to check if whether the Node.js is installed properly. And here it shows the version of Node.js installed in our device. So here we can see that Node is installed properly. Next we need to install TypeScript. To install TypeScript, we need to run the command npm node package manager install -g globally TypeScript. If you run this command, the TypeScript will be installed. The TypeScript will be installed worldwide with this command. This implies that each project you create on your computer can use TypeScript dependencies without having to reinstall the TypeScript package. So after running this, the TypeScript will be installed. Since I have already installed, I'll clear this. So after installing TypeScript, to check if whether the TypeScript is installed properly, to check if the compiler is installed, just type tsc TypeScript compiler space hyphen version, and here you can see the TypeScript compiler of version 4.5.4 is installed. Now that we know how to install node.js and TypeScript, now we'll go to Visual Studio and see the examples. So let us see the different types of variables available in TypeScript. So for variable declaration, TypeScript follows the same rules as JavaScript. Variables can be declared with the commands like variable, or we have let, and we have const. So these are the three types of variable declarations available in TypeScript. We'll see them one by one. Variables can be declared in TypeScript using the var keyword, just like in JavaScript. The scoping rules are identical to those in JavaScript. For example, we can declare a variable of parameter age, and it is of the type number, which is equal to say 45, something like this. And similarly, we have let. So let is a ECMAScript 6 introduced two new types of variable declarations in JavaScript using the keyword let and const to solve the issues with variable declarations. These additional sorts of variable declarations are also supported by TypeScript, which is a superset of JavaScript. For example, we have, let's say, employee name is equal to John. Similarly, we have constant. Constant variables are declared in the same way as variable and let variables are. Constant transforms a variable into a constant whose value cannot be changed. The same scoping constraints apply to constant variable as they do to the let variables. For example, we have constant num is equal to 100, something like this. Next, we will look at the different data types in TypeScript. We have different data types like number, string, boolean, array, etc. So number, first we'll look at the number. Just like JavaScript, TypeScript supports number data type. All numbers are stored as floating point numbers. These numbers can be a decimal, hexadecimal. For example, say let first number 1, 2, 3. So let second let third number is equal to, this is of the type, now we will write octal. and don't forget to put colon, otherwise it will show an error. Let fourth, now we'll declare the number of type, say binary. So TypeScript supports number data types, like the numbers can be stored in floating point numbers or decimal or hexadecimal, octal or binary. So this is basically a number, and this is hexadecimal, this is octal, and this is binary. These are the different number methods in TypeScript. The method toExponential returns the exponential notation in string format. ToFixed returns the fixed point notation in string format. ToLocate string converts the number into a local specific representation of the number. ToPrecision returns a string representation in exponential or fixed point to be specified precision. ToString returns the string representation of the number in the specified base. And value_of returns a primitive value of the number. Next we have string. The another data type which we have is string. String is another primitive data type that is used to store text data. String values are surrounded by single quotation marks or double quotation mark. For example, we say declare it, let employee name string of the type string is equal to Johnson. So this is of the type string. The different string methods in TypeScript are method character at returns the character at the given index. Concatenate returns the combination of two or more specified strings. Index of returns an index of first occurrence of the specified substring from a string, and -1 if not found. The method replace replaces the matched substring with a new substring. And the method split splits the string into substrings and returns an array. ToUpperCase converts all the characters of the string into uppercase. ToLowerCase converts all the characters of the string into the lowercase. The next type which we have is Boolean. Boolean values are supported by both JavaScript and TypeScript and stored as true or false. Example for Boolean is, say, let. Here note that the Boolean with small b is different from the Boolean capital B. So the uppercase Boolean is an object type, whereas the lowercase Boolean is a primitive type. It is always recommended to use the primitive type Boolean, that is the lowercase Boolean, in the code, because while JavaScript coerces an object to its primitive type, the TypeScript type system does not. The TypeScript treats it like an object type. The another data type is of the type array. An array is a special type of data type which can store multiple values of different data types sequentially using a special syntax. TypeScript supports array similar to JavaScript. There are two ways to declare an array. One is using the square brackets and the other is using a generic array type. Example, this is one type to declare with the square brackets. And the other type is to use the generic array type. Both methods produce the same output. Arrays can contain elements of any data types, numbers, strings, or even objects. Arrays can be declared and initialized separately. These are the different array methods in TypeScript. We have pop that removes the last element of the array and returns that element. And push adds the new elements to the array and returns the new array length. Sort sorts all the elements of the array. And similarly, we have concat index of copy within, fill, shift, splice, unshift, includes, join, last index of that returns the last index of the element in an array. Similarly, we have slice, toString, and toLocateString. Similarly, we have tuple, union, any, void, and never as the data types in TypeScript. Next, we will look at the if statement in TypeScript. An if statement can include one or more expressions which return boolean if the boolean expression evaluates to true. A set of statements is then executed. And in if-else condition, an if-else condition includes two blocks, if block and an else block. If the if condition evaluates to true, then the if block is executed. Otherwise, the else block is executed. And we also have else if. So the else if statement can be used for if statement. Next, we will see loops in TypeScript. TypeScript supports for loop. The for loop is used to execute a block of code a given number of times, which is specified by a condition. So this is the for loop. The first expression is executed before the for loop starts, and the second expression is the condition for the loop to execute, and the third expression is executed after the execution of every code block. Here in this example, I is equal to 0 declares and initializes a variable. The second condition, I is less than 3, checks whether the value of I is less than 3 or not. If it is less, then it exits the loop. The third statement increases the value of I by 1. This loop will execute the block 3 times until the value of I becomes 3. Now that we have seen loops, we'll see the functions in TypeScript. Functions are the primary blocks of any program. Functions are the most important part since it is a functional programming language. With functions, we can implement the concepts of OOPs like classes, objects, polymorphism, and abstraction. Functions ensure that the program is maintainable and reusable and organized into readable blocks. While TypeScript provides the concept of classes and module, functions still are integral part of the language. For example, we have function sum. So this is the example of function. Classes in TypeScript. Now let us look at the classes in TypeScript. So in object-oriented programming, classes are fundamental entities used to create reusable components. TypeScript has been primarily a functional programming language, where inheritance is prototype-based. Functions are used to build reusable components. Let us see an example for the classes. Employee name. So we'll create a class employee and we'll provide employee ID, employee name. So the TypeScript compiler will convert the class to the JavaScript code using the closure. And the constructor is a special type of method which is called when creating an object. In TypeScript, the construction method is always defined with the name constructor. So in this example, the employee class includes a constructor with the parameter employee ID. In the constructor, members of the class can be accessed using this keyword. Example, this.employeeID. It is not necessary for every class to have a constructor. So far in this video, we saw the variables, different data types, loops, functions, classes, and constructors. So with that, we have reached the end of this video. Thank you so much for being here. Keep learning and stay tuned to Simply Learn.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.